So section 8.3, we are going to use a different formula to do the hypothesis testing. The 5 steps is the same, but there will be some different in terms of using the formula. Also, you will see in the step, we have to change some skills. In other words, we have to use different table. Previously, we are using Z table. Now we have to switch to T table. Why is that? So let's try to use some examples here to understand what's going on. So this example here, claim average number of infections per week. That's probably talking about like some hospital, right? Is 16.3. That's their claim. So to prove or disapprove that statement, that claim, randomly select 10 weeks. Find out the average is about 17.7, average number of infections per week. The sample standard deviation is 1.8, everybody. Be careful here, this statement here, right? So when they say the sample standard deviation, that means what? That's what? That's S, right? That's not sigma. Sigma is the population standard deviation, but here we are talking about sample standard deviation. Remember, previously in the confidence interval, we have a section using the T table, right? In that table, we are using the T formula, right, to do the calculation, to find out what's the confidence interval, right? Similar here, we have used T table, right? Question, is there any evidence to reject the claim at alpha equal to 5%? So everybody, sometimes if we don't mention that, say, they didn't say what's the alpha, by default, alpha is 5%. It's like when we talk about the confidence, if we don't mention the confidence specifically by default, the confidence is 5%, 95%. So when we try to write down this step number 1, write down H0, H1, right? That's pretty straightforward, right? H0 always equal, average equal to 16.3, right? H1, because they did not say it's higher or lower by default, not equal to. Number 2, doing the calculation. In this case here, we are using the T statistics, right? Previously, we are using the Z formula, Z statistics, because we are using like sigma. Now we are using S, the sample standard deviation. Remember, S and T, they are kind of together. So whenever you see S, we are using T formula, right? You plug all the numbers here, you find a 2.46, right? Based on our previous calculation, after you find out 2.46, that's your test value. What do you do next? Is try to find out from the p-value, right? The challenge we have here is we actually got stuck. Based on that T table we mentioned earlier, right? This is a T table. It's a 1-page T table, but it's a simplified T table. They don't have all the numbers we need, right? So in this case here, we got trouble to continue. Even though I have in the notes, I have write down the p-value is approximately equal to 2.5%, right? So actually I find out that from a different way, not from that T table, right? So in other words, the normal way we got stuck. We actually cannot continue this route, right? So in other words, we have to use some other way to do this, some other method to do the hypothesis testing, everybody. This is what we call 2 method for the hypothesis testing. Everybody, you have to wake up. Yes, someone was asking the degree of freedom. We will come back to that. Okay, so there are two ways for the hypothesis testing, right? P-value method, we mentioned that step by step from all the previous examples, right? So 5 steps, very similar. Critical value, also 5 steps. If you compare this eyeball to eyeball here, right, side by side, you will see the only difference here is actually step number 3. Step number 3, right? So previously, you are trying to find out what's the p-value. Now, you are trying to find out what's the critical value. So our question is, what do you mean by critical value, right? Well, remember, we, like a moment or maybe 1 hour ago, we mentioned something about critical value, critical region, right? So that's the concept come back here, okay? So we are going over details by some examples, okay? Now, let's do the hypothesis testing using the critical value to do this hypothesis testing, 5 steps, right? The same information we are given, average 16.3, sample standard deviation S 1.8. You do the calculation, find out 2.646, right? The same information we have, nothing special. The special, the different, we are coming from step number 3. Remember, previously we got stuck here. So instead of finding p-value, we are trying to find out critical value. Everybody, now is a tricky time. I do need your attention in the next 2 to 3 minutes. How do we find out critical value? Wake up. So how do we find out the critical value? Determined either the z-value, the p-value, or critical value is all coming from table, right? So which table? Are you checking the z-table? Are you checking the t-table? Determines which formula we are using. Because we are using t formula, that means we are using t-table. Is that clear? Right? So now we are trying to find, how do we find out the critical value here from this t-table? Which table I'm talking about? I'm talking about this one, right? So how do we find out the critical value from this table? Everybody? Previously, when we use this table, I mentioned like this 1 tail, 2 tail, forget that for the moment. We will come back. And right now, it's time to be back for this one, right? So when we are doing the hypothesis testing, tell me, this is 1-side or 2-side test? Everybody, can you type your answer on the message window? It's 1-side or 2-side test? It's 1 tail or 2 tail test? Yeah, it is 2 tail, 2-side, okay? Right. So in other words, if you are looking at the t-table, everybody, you are looking for the second row here. Is that clear? You see that 2 tail? Follow me on the table here. So we are using the second row here, right? Remember, previously when we talk about the confidence interval, we say we started from the bottom, the confidence interval, right? We didn't use any of those 2 rows. Now it's time to use those 2 rows because here we talk about 1 tail or 2 tails. So 2 tails is coming from here. Now, what's alpha we talk about? Alpha is 5%. Is that right? 5%. So let's see. This number here, what are those? That's alpha. So we are looking for this row here. This row here, which one is alpha is 5%? That's this row. This column. Everybody, follow me. Very, very important, the next 1 or 2 minutes, right? So we are looking for some number in this column here because we find out 0.05, which is alpha here, right? 2 tails. Now we are going to select one number from this column. Which number from this column determined by, you see that DF means what? Degree of freedom. So degree of freedom here is using the n minus 1. Remember the formula? N minus 1, right? What's the sample size we have, everybody? We have 10 weeks, is that right? The hypothesis average number of infections, 10 weeks, right? So 10 minus 1, everybody? Degree of freedom, 10 minus 1, 9, right? So corresponding to the column here, 5%. Everybody cross this one here. Follow me? 2.262. One more time. So we are using this one here, degree of freedom, n minus 1. We got a line cross this, the one we decided from this column, because 5%, that's alpha from 2 tail. 2.262. What do we call this number? Critical value. Are we good? Critical value, okay? So critical value, now we find out here 2.262. Now we can draw the bell-shaped form, everybody, on your paper when you are working on homework or exams, right? 2.262 here. And then step number 4 is try to make a decision. Everybody, this one is actually relatively easier to understand. So critical value, that's like 2.262. We find out here. What's the data? The calculation tells you. It's coming from step number 2, right? Step number 2 tells us the test value, 2.46. That's coming from a data, right? So 2.46, you can write down that here on the bell-shaped form, right? So 2.262, that's a critical value. You can consider this as like some vertical line, reference line. It's like some reference line here you can use. So what you are trying to do here, after you draw the bell-shaped curve, find out what's the critical value, draw a reference line here, the vertical line here, and then compare with our data. Our data, we got 2.46. That's the evidence we got from the data, right? Everybody? Now we compare this point, right, to the center. Relatively speaking to this vertical line, our data is further away from the center. Is that clear? It's further away from the center. Now, let me see if I can draw something here. No. Hold on. Yeah. So this data is coming from our calculation, right? It's further away from the center. What's center, everybody? You can understand this center as what? H0 as our center, okay? So if the data is further away from the center, so you can understand, like, because it's further away, that means the data is not supporting HO, right? Because it's further away, relatively speaking to this vertical line. So it's further away, that means not supporting, means what? Reject HO. You see that conclusion here? Is that clear? So now people will ask, what if we find out the data from the calculation, instead of 2.46, now I got 2.16, like somewhere here. If I find out 2.16 here, then we say now the data is more close to the center. In other words, we are supporting HO. In other words, we are accepting HO. Is that clear? Right? So we can continue to do this. Why? Because here, check, this hypothesis testing here is one side or two side, right? It is two side. So in other words, there's another one here corresponding negative 2.262. Right? So as long as you got the data from the calculation, 2.16 or 2.06 or negative like 1 or negative 1.5, any number here, negative 2.16, as long as in this inside, right? What do we say? accept HO because we are close to HO, right? So as long as the data calculation all in this area, we are accepting HO. But if your calculation is either here or here, then what do we say? Reject HO because we are further away. The data is further away from HO. That means what? We reject HO. Everybody, this way, critical value is more intuitively understandable. Is that right? Follow me? So, in fact, critical value is more powerful. It's more powerful because that one can actually solve both cases. Remember, right? Previously, when we used the p-value, we got stuck. Now, using the critical value, we can solve that. So reject HO, what's step number 5? Summarize. Reject HO, that means what? HO is not right. So HO is not right. That means the average number of infections per week is not 16.3. Follow me? So that's the statement we can make, right? So we are making a claim. Claim is not right. Is it right? Let me see. Let me double check that. So reject HO. Yes. Reject HO, reject the claim. We don't have that confidence to support the claim. So in other words, reject the claim. Any questions? Everybody, we cover a lot tonight. I'm thinking you probably need some time to digest, to understand that. I understand once I introduce these two methods here, right? This p-value method and the critical value method, you definitely got some questions, right? I mean, I'm thinking tonight we stop here. So try to spend some time to understand each part, the lecture notes, and then try to work on the homework questions. Understand which section using